Intermolecular forces and surface tension in water. Like many other things in chemistry, the shape of a drop of water is determined by the forces between particles. Water molecules exert hydrogen bonding forces on other water molecules due to the extreme polarity of the OH bonds. Water molecules inside the drop are pulled uniformly in all directions, but the net force on molecules at the edge of the drop is inward. When water comes out of the end of a dropper, this inward force pulls the drop into a compact, roughly spherical shape. The term surface tension is used to describe the force that holds the drop together in this shape. When the drop is released, surface tension maintains the drop's spherical shape while it falls through the air, since the attraction of the hydrogen bonds is stronger than any other force acting on the drop. Suppose the drop lands on a waxy, nonpolar substrate. We observe that the water beads up. The base of the bead of water curves away from the solid surface. This happens because the water molecules are more strongly attracted to each other by the forces of polar bonds than they are to the waxy surface by nonpolar interactions. The surface tension of the water droplet is much greater than the attraction of water molecules to the surface, so the molecules continue to draw together in a compact shape rather than spreading out over the surface. However, if the substrate is polar, the situation is different. The drop spreads out and flattens to cover much more of the surface. On a polar substrate, the attraction of water molecules to the surface will be similar to their attraction for each other. As a result, the surface tension is broken up and the drop loses its shape. The shape of water droplets is determined by the relatively high surface tension of water, which reflects the strong hydrogen bonding between polar water molecules. Key takeaways. To summarize, strong hydrogen bonds between water molecules give water a high surface tension. On a nonpolar substrate, water beads up because the attraction of water molecules to each other is stronger than to the surface. On a polar substrate, water drops spread out because the water molecules are attracted to the substrate about as strongly as to each other.